Lastly, I want to show you how action potentials are depicted because you'll see this way. So what this is on the left, an action potential, just like you've seen it, changes in member potential over time. Notice the scale of the x-axis. It's in milliseconds going from 0 to 4. So around here, it's about 2 milliseconds. And we've got those different components of the action potential that you should be able to draw. How this is depicted often is like this. Notice the scale here. This is 10 milliseconds. So 2 would be like right here. So it's just drawn as a big spike. Change in millivolts, same change in millivolts, but it's just shown as a big spike because we've zoomed out on the scale of the x-axis. So you'll see action potentials depicted as just spikes. And that's because it's all or nothing. You can just show it as a single point like that. This would not be how you draw the detail, though, for exam purposes. However, what I want to do here is now have you think about what this means for stimulus strength. Stimulus strength, when you're talking about a graded potential, is going to change the amount of depolarization or hyperpolarization. Since action potentials are all or nothing, the action potential size cannot change. So let's look at this example here. If we have a stimulus here, so this is the voltage of a stimulus, it's below threshold. Doesn't matter how long this lasts for, well, it would eventually. What's this going to look like in terms of a change in membrane potential? If we're depicting the action potential as a single spike or no spike. In this case, we'll have no spike. Okay, we might have actually had a little blip, a little depolarization, but there's no action potential. What if we have a stimulus that does cross threshold with that voltage? We might have some spikes. Here, there's just 4 because of how long that stimulus lasts. I wouldn't expect you to know this was 4. Now, let's look at what happens if we have a stronger stimulus, a stronger depolarization for our stimulus. Are we going to have larger spikes? No, but we will have more spikes. So more action potentials will be able to be fired, and that's depicted like this. So the relationship between stimulus strength and action potential frequency is the higher the strength of the stimulus, the higher the frequency of action potentials, not the size of the action potentials themselves.